Hello everyone, this is Chen Shu, joined by Sarah and Karthikeyan from Group 3. We're gonna present our application about climate data processing. About why do we choose this topic? We think climate changing is always a critical research topic across the world, and there are a lot of databases built upon it, and also the data is collected daily with a large amount of stations, and they are really hard to analyze because the amount of the data and it's daily. When you research in climate, you really want the data be summarized either in months or years. So that's here we find out mapreduce can remarkably reduce the size of data before other process like store into database or display it in our case. We finally decide to use the database called NAOO Global Historical Climatology Network Daily. I will introduce the data sets in next page. For our preparation, we first identify the original data. The data is recorded daily by each station and stored by year in a single CSV file, such as 2000.csv. It contains all the data collected daily from every stations across the world. And here is the example. The first element of the one piece of data is the station ID, and the next one is the date. This one is what's the element about, and this is the value. And also they have multiple flags at the end, but we didn't really consider them into our application. After that, we start working on our application ideas. So we basically decide to download the year files as needed and then get a monthly summary for selected stations and then display the data by graphs in a website. In order to do that, we decide the implementation platforms are mapreduce, which is hadoop, and we use the similar structure in our programming assignment. And then for the graphics, we choose the JavaScript framework to do the picture drawing and stuff. And then for the web display, we choose PHP server just because NGIT support PHP and we have experience with PHP in previous. So let's dig something into the designs in detail. For the programming languages we use is Java for Hadoop, and for the whole website display, I use the PHP, JavaScript, jQuery, and HTML as well, and also some online CSS. But yeah, that's not the core point. And for detail processes, it's similar to our idea, but some more steps we have to take. The first one is download the files and then gathering the station IDs. I basically created a PHP script to generate all the IDs we need, and then we use them in our script to filter through all the stations. And then we just run our script with all the files and station IDs for a monthly summary, and then we download all the results and then put them on the PHP server, basically this. And finally, we can visualize our data. For the visualized part, you guys can check the link after, I think after the presentation, we have one page saying where the link can find. And then I will pass to Sarah for some project outcomes.
Hi, my name is Sarah Mehman, and in this slide, I will discuss project outcomes. In first part, we work on weather summary for New Jersey in years 2000, 2010, and 2018. We calculated maximum and minimum temperature of these years, and then we plotted values of each year maximum temperature and minimum temperature in terms of graph. In second part, we compare maximum temperature, minimum temperature, precipitation, snowfall, snow depth for years 2000, 2010 and 2018 of New Jersey. Then we plotted graphs for each attributes. In this slide, there is a link for our graphical user interface. So you can go and check that how it looks and how it works. So basically you can see all graphs which we discussed in previous slide in this interface. So this is the small picture of our results which we got after running our code in Hadoop platform, that how our output looks like and what we achieve in results. This is a screenshot of our graphical user interface, that how it looks. As you can see that years from 2000 to 2018 are on x-axis, temperature is on y-axis, and here you can move cursor to find maximum temperature and minimum temperature of particular year. This is the screenshot. You can get actual idea when you go to link which we provide in slide 8. So this is a temperature summary in 2010. You can get this plot by clicking temperature tab on left side and choose year 2010. Then you can get this plot which tells whole temperature summary in terms of Tmax and Tminimum of year 2010. This plot shows the comparison of maximum temperature between 2000, 2010 and 2018. You will get this plot by simply clicking compare option on left side, and then you will get different attributes like maximum temperature, minimum temperature, precipitation, snowfall, snow depth. After clicking maximum temperature, you will get this plot. This plot shows the comparison of minimum temperature in New Jersey between 2000, 2010 and 2018. You can get this plot by the same method by just clicking compare option on left side, and then you will get different attributes. Then select minimum temperature, and then you will get this plot. So this is a screenshot 5 of our graphical user interface. You can go and see our interface, how it looks and how it works by clicking the link which we provided in slide 8. So this one shows the comparison of precipitation in New Jersey between 2000, 2010 and 2018, and you can get simply this plot by clicking compare, and then you will get different attributes, and then select precipitation and you will get this plot then. So this is a screenshot 6 of our graphical user interface. It shows a comparison of snowfall in New Jersey between 2000, 2010 and 2018. So you can easily get this plot by just clicking compare and select option snowfall, and you will get this plot. So from next slide, my project group member Karthik will continue. Thank you so much.
Hi, this is Karthik. I'll be talking about scalability and performance degradation in this slide. First of all, scalability. Scalability is an attribute that describes the ability of a process, network or software to grow and manage increased demand. A system or software that is described as scalable has an advantage because it is more adaptable to the changing needs or demands of its users or clients. Here, the file as we run the program in different cluster nodes, we see that the file size and the time, the execution time of the whole data file have a linear relationship when using the same amount of nodes or cluster size. So when the file size increases, the execution time also increases. Uh, Also, it varies with the different amount of cluster size of nodes. The second one is the increasing node size has a various result. The finish time or the execution time is reduced by 20 to 40% when we increase the number of nodes. So these are the two different features that we saw during running the program. The second one is performance degradation. We have not encountered node failure in our experiment, but in some cases we face the slowdown of some data node, and it has some deteriorating effect on whole cluster. So the second one is we face hardware degradation during shuffling process in mapreduce program. It was a choke point. It increased entire job time of our task. So this is the table where we can see the total input size that we have given, and we have tested with different node clusters. So for 1.1 GB of file, we see the execution time is around 620 seconds. As we increase the number of nodes, the time decreases. Same as we see for the 3.27 gigabit file and for the 6 gigabit file. This is the performance metrics graph with respect to the table that we define above. Here we can prove that the relationship between the input data size and the execution time as a linear relationship, or approximately a linear relationship, where we can see the increased data file has like increased execution time. Also, with increased cluster size, the time decreases. The conclusion: our application achieves the goal we desire. The main goal is to feed in the data, use the mapreduce function to in the Hadoop cluster with a different number of nodes, and getting the execution time reduced. Through the whole project, we got a better understanding of mapreduce function, performance degradation. The third one is parallel computing is a surprisingly efficient way to process large data files. So the main strategy is mapreduce function, which suppresses the data, the parallel computing is a huge method for it. And the final thing is, from the climate change data, we see that there's no critical climate change in the past 18 years. But then if we look at the data for more than for around 100 years, from before 1800s to 1900 and the 2000s, we may see a critical change over the face of time. So over the 200 years, we may see a noticeable change from the data. But then for the past 18 years of data, as we processed from 2000, 2010 and 2018, we didn't see a much critical change with the maximum temperature or minimum temperature, precipitation or snowfall. Maybe a slight change, but then not a huge critical change. Thank you.